Hello and welcome to another video. In this video we're going to be working on reorder list. And this problem, you're given the head of a linked list and it can be represented like this. And you want to reorder the list in the following form, so it goes first, last, second, second to last, and so on. You can't modify the list nodes, only nodes themselves can be changed, or you can't modify the values. So you could do something like take all the values and do something with those if you want to, but I guess they don't suggest that. But like the better solution, the in-place solution. So if you think about it, what we need is like the first, then the last, then the second to last. It's basically the same as kind of the same problem we were doing yesterday, where you chop the list in half and you reverse this. So let's see what happens if we do that. So if we have 1, 2, and the second part is 4, 3 reversed, so it'll be like this. Well, now it's just basically like a merge two list, right? Like we can just take 1, then we take 4, then we take 2, then we take 3, and we can keep doing that with our lists. Same thing here. We can chop it either like this or like this. Either one's fine. So let's say we chop the first list has 3 elements and then the second one has 2. So the first will have 1, 2, 3. And then the second element will have 4, 5 reversed. So it'll be 5, 4. Then we can do the same kind of thing, right? Where we just take like the 1, then the 5, then the 2, then the 4, then the 3. This is just like a merge two list. Pretty straightforward problem. And so the main thing is like, how do we do this whole like chopping in half? What do we have to do with our pointers and all that stuff? So let's walk through, as I suggested. You want to try this with an even length list and an odd length list. Make sure it works for both. And I would suggest, like I said, for even yesterday, use around 2 to 4 nodes. Or not 2 to 4, 4 to 6. And for odd, 5 is a good number. 3 to 5, I usually just use 5. So we can just try these two, try some kind of algorithm, and then see if it works. So let's just make a list of 1, 2, 3, 4. I'm just going to draw normal circles to keep it simple. So 1, 2, 3, 4. And so the idea is we want to chop this like this and then reverse. So the reverse list, I'm not going to describe in too much detail because that is like a problem 2 days ago and yesterday, so you can just look at one of those. But essentially, we can do this one of 2 ways. We can do a length, which is what we did yesterday, or you could have a fast and a slow pointer. So we'll try the fast and the slow pointer today because we did the other one yesterday. So let's say our fast pointer is this one and our slow pointer is this one. And then you want to come up with like some kind of constraints to make sure that so your slow pointer needs to end up at the node right before the halfway point where you're going to make the chop, and then your fast pointer can be whatever, just some kind of ending condition. So just by quickly trying something like we basically want this slow pointer to move up once. So in order to do that, we can say like while the fast pointer has a next and a second next, that would work, right? So like we move the fast pointer up once by 2 nodes, and then it has to have a next and like the next, because the fast pointer will move 2 nodes at a time, slow pointer will move 1 node at a time. So that makes sense to me. So we could say like fast has to have this, and fast.next.next also has to exist. And so that should work. So essentially, let's just walk through that. So in the beginning, the fast does have a next and a second next. So it will move up like this. Then our slow will just move up once. Then the fast does have a next, but it doesn't have a second next, so we'll just stop there. And let's also see if that works, by the way, with like 1 node. Like, let's see what happens if we have 1 node. So actually, it will work for 1 node for sure. It will also work for 2 nodes for sure. Yeah. So so here, now that we have our fast pointer, our fast pointer will not necessarily be the head of this like second list. It'll just be like somewhere near the end. And we can also try this for an odd list really quickly, because like I said, you want to try it for odd and even. So let's say we had a 5th node. Let's try that. So with that same condition, so right now our fast has a next and a next, so we'll move it up 2. Slow moves up 1. Then our fast has a next again and a next, so we'll move it up 2. Slow moves up here. And that's fine because our first list will have 3 items, or our second list will have 4. And it's totally fine to either have the first list 3 or second list 3 if it's odd. Like it's totally fine to have that extra one in either one. It doesn't really matter. Yeah. So let's just go with this list as our example. So our slow will be here. We basically don't need the fast anymore. So we can just get rid of that. So then what we need to do is we need to make the head of our second linked list, which is pretty easy. So wherever our slow pointer here, we'll just make, we'll just make the head of the new linked list there. It'll just be the next pointer of the slow. Then we can just say like, okay, let's take whatever the slow is and let's make its next equal to null to break these two apart. Then for whatever list we get, we do a reverse. So that's just, we're going to run like a simple reverse. And then we're going to have something that looks like this. So then from here, we have the head of the original list in our variable. It's passed into the function, so we can use that and this. And then we just have to build a new list from these two. And yeah, that's pretty much all we have to do. So there's a bunch of ways to do this. What I'll do is I'll just make a dummy node. So I'll just make like an empty node where we're currently at, and then I'll just like alternate going through the lists. So we can start with our empty node going to the first node of list 1. Then we move up list 1. Then we break this thing over here. And the way we're going to break this over here is as we're building the list, we will have one more pointer to like where we're currently at. So we'll start over here. Then when we have this node, we'll move over here, and then we'll just say like the next of this list will be none. Then now that we took this node, we need to take this node. So we will, so this node will point over here, and then we will move this up, and then we will take this, move it up here, and get rid of this. So just basic node like pointer manipulation. Then we do the same thing. So we say, okay, let's move this to point to the next node of list 1. We'll move up list 1, and then we break that thing there. Then we have this point to the next node in list 2, and then we'll move up list 2. So now our list 2 is out of bounds. And yeah, and then we have one more node here, so we will have it point here and have this be out of bounds as well. Then finally, when we have this whole list, we just need to set our, or whatever we have. So this function should return void, and the head of the new list should just be the one after this dummy node we made. So we'll call this like dummy, we'll store this in a variable, and then we basically make our head of the linked list equal to this thing. And then that will be correct. So it'll be 1, 5, 2, 4, 3, which is that. So let's break down the steps one more time. First, we're going to use a fast and a slow pointer to break the list in half. Then we will reverse the other half, and then we will just merge the two lists and assign the head to the new head. And yeah, so let's code that up in Java. So we're going to say, remember our original step is just make the fast and the slow pointer the head of the list. So we can say list node slow equals head, and list node fast equals head. Then remember our criteria was what the fast needs to, first of all, it needs to exist. It also needs to have a next pointer and a next pointer. So while fast does not equal null, and fast.next does not equal null. You can do this in like a bunch of different ways, but this is one that works. And fast.next does not equal null. Okay, so if that's the case, we're going to move both of these nodes up. So slow equals slow.next. We don't need to check for slow being out of bounds because fast always travels faster, so we just check the fast. Then fast equals fast.next. So it moves up 2. So now slow is going to be the node right in front of our like new linked list. So we need to make a node there, save it. So we can say like list node. Maybe we can rename this even to like head 1. That way it'll be easier. So we can say this is like head 2 equals slow.next. Then we need to chop the two lists from each other. So we'll say slow.next equals none or null. Okay. So now head 2 is the head of the new list, but it's not reversed. So now we basically need to reverse this new list. So we can use the previous and stuff that we did before. So list node previous equals null. And yeah, then we can say while head 2 does not equal null. So this is basically a copy paste of the list reverse problem from like 2 days ago. We can say net or temp or something. You can use a better variable if you want. List node temp equals head2.next. So we make it the next node. Then we make the head point to the previous node. So head2.next equals previous. Then we make our previous node our current node. So previous equals head2. And finally, we need to move up our head2. So head2 equals temp. Okay. So now at the end of this, so head 1 is the head of the first list, and previous is the head of the second list. So we can make head 2 equal to previous, just so we have like better variables, I guess. So we can say head 2 equals previous. So now head 2 is the head of the second list, and head 1 is the head of the first list, and the second list is reversed. Now let's make our dummy node. So we'll say list node dummy, and I believe here if we give it nothing, it'll just default to 0 and null, which is fine. So new list node, because I think it has like a few constructors. So now all we have to do is go through our 2 heads of the lists. And yeah, so let's do that. So we can say like while, but we also need like a current node where we're at. So we need a dummy and a current node. So we can say current equals dummy. Did we use current before? I don't think so. So we'll make one more list node. So you definitely can write this like cleaner, because there's like so many list nodes, you can reuse variables or whatever you want. So essentially now we are just getting, so we're going to traverse list 1 and list 2 with the head 1 and head 2 until they both point to none and make our new linked list. So we can say while, and also if our linked list is odd, then our first linked list will have more numbers. So we have to be careful there as well. So while head 1 does not equal null, and head 2 does not equal null. And the only thing about Java is you can't have like truthy stuff, so you can't just say like while head 1. You have to actually check for null. So yeah, so if this is the case, then let's take our node for head 1. So we can say like list node, or actually we don't need to do that. We can say current.next equals head 1. And we can say head 1 equals head 1.next. Then we move our current up, so current equals cur.next, and finally we chop off that connection, so cur.next equals null. So now we actually have to check if head 2 isn't null, because like let's say this list was 3 and this list was 2, then we're going to be here. There's going to be a case where we're here on list 1, but list 2 is out of bounds. So we do have to check for that. So we can just say if head 2 does not equal null. Let's do all this like stuff again. So cur next equals head 2 equals head 2.next, cur equals cur next, and this should all be fine. So now remember this is void. So now what we need to do is we need to make head 1 the head of our new linked list, and the head of our new linked list is just dummy next. So we can say head 1 equals dummy. And the best part, praying to see that you don't have an error. So let's see. And I actually am not like copying this on somewhere else, so it would be very lucky. And I do have an error. Okay. So let's see what we have. So we have 1, 5, then we have 2, 4, but we don't have our last node. Okay. And that's because I use an and here and we need an or. Okay. Okay, nice. So yeah, just basic like, can you do a list reverse? And like I said, most of the tricky solutions in linked list problems is just, do you recognize when to reverse a part of the list? So this is basically that. Do you recognize like to make this pattern, I need to chop it in half and reverse the second half? And then if you can do that, then you basically have it. And as always, let's go through the time and space. So time is, so let's recap what we did. So we went through our list with a fast and slow pointer, which is O of n. We reversed the second half, which is O of n. And we reconstructed a list using both halves, which is O of n. So all these things are O of n. Space. We just used some nodes, and that's, like I said, for any previous problems. Linked list problems, 95% more, you're going to just want to be using constant space. You almost never have to like recreate variables. It's mostly just pointer manipulation, rearranging them the way you want. And definitely there is a lot of room here for writing clean code. So the linked list problems are pretty good ones to practice writing clean code, because you have so many you have so many variables and stuff. So definitely as clean as possible would be good, especially in Java where it's more verbose. But yeah, I think that's going to be all for this one. If you did like it, then please like the video. Please subscribe to the channel, and I'll see you in the next one. Thanks for watching.